And like I was just saying, is that today's section is going to be relatively shorter. What's it? We're on section 43. Ooh. Yeah, I want to say it's section 43. Basically, it's a continuation from convolutional neural nets, right? So last time we kind of saw the way convolutional neural nets can be applied. Basically, it's another deep learning. It's used a lot for image recognition, like I said. That's probably like the most most visual stuff that comes out, just because of the fact that it's easy to like kind of share and explain and show all those things. But it can be used for other things that basically the key is to find patterns, like very closely knit patterns. So that's why visuals are really great. So for example, you know, like I said before, instead of finding just like lines or whatever, or whether or not this pixel's on or off, we can actually say, well, okay, is this group right here, does this look like a face? And you can actually basically train convolutional neural nets with many convolutional layers to build like high level features. And so really what comes down, just kind of repeating what convolution a CNN does. Basically, it takes something that's like an image, which has a high spatial information. Basically, it's just a bunch of pixels on or off, right? More or less how bright they are for each color. And then taking those images or that image and breaking it down and say, well, what's in that image? And basically it does this by first finding like, you know, different color patterns, different like, what's it called? Like lines, like if it's a vertical line, like outlines and stuff like this. And then they start combining it to make more complicated features, which are like, you know, are there circles in there? Are there like squiggle lines? Are there, you know, other kind of like shapes that are going on there? And then it goes further and further into it, basically finding more patterns and say, okay, well, these set of patterns, this looks like a face, or this set of patterns looks like a dog, this set of patterns look like a cat. And so you can basically build these, their goal basically ends up being the very end, right before you pass it through a neural net, like our MLP, usually called a fully connected layer. Basically, you have a set of high-level features, and you say, from these high-level set of features, is this a cat, dog, or whatever you're trying to classify on? So this is the way really convolutional neural nets can be useful. But again, like I said, mostly done with image, but you can do things, for example, with speech recognition, where the patterns of your speech, it doesn't matter what volume or what specific tone you're hitting, you're basically combining this sound information to form a word or different phonemes and such. So there's a lot of applications of CNNs. So what we're going to talk about today is just a few like applications and like what we can do. And the first thing we're kind of going to talk about is just how to how you would visualize this. So the curriculum actually has like a lab that goes through it pretty well. But I wanted to show you just a few examples of what this would look like from like out in the wild and what people have done so far. And so the big thing about it is just having the different resources. So I'm going to start sharing my screen. Okay, and so, all right, so I have a little notebook here. And so what one thing the curriculum actually talks about, and it's an important part, is that really deep learning is a lot of ways a black box. Like we kind of don't know what's going on. So in order to understand like, well, how well is our convolutional neural network working? Like we can see it works, but we're like, well, what is it doing? We can actually basically apply the convolutional layers, I should say, the different filters, and seeing what is it detecting. So this is actually directly from Karis, a blog post, which I'll go to in a second just to kind of show you. But what here basically is like this convolutional convo one, basically it's our different layers and what convolutional layer we're looking at. So for example, this is the very beginning part of the layer, and you can see here, mostly it's detecting like little splotches. Like if you imagine this whole thing's an image, these are the things that's emphasizing on. It's looking for these squiggles, looking for these splotches. You can see some very basic patterns going on here. As we get into like a little further into the other filters, you can see the filters become a little more complicated. Okay, they're no longer just random spots. You can see here, for example, these are more like a structured dot structure. You can see here these squiggly lines, but they're all going vertical. And then we have some diagonal. We also have this kind of interesting pattern right here. So you can see there's different filters, and you can see too they're different colors, and saying this is emphasizing is looking for dots that are of this kind of color or in this kind of spectrum. And that's when they would fire off and say, oh, these are really important parts. And this would be one of like, essentially one of those filters actually passing through. And then as you can see, as we get into deeper layers, so convolutional layers on convolutional layers and convolutional layers, finding patterns within patterns within patterns, they start basically developing this library of more complex images. So you can see here, for example, these filters right here are detecting much more complicated. As we get into the further layers, you can see much more complicated patterns right here. And these are all basically built from combining these different filters together to say, okay, well, in this filter happens together. We tend to see these kind of patterns. And this is what the convolutional layer is basically saying. This is what I'm like, I don't want to say like it's like seeing, but it's like, oh, this is what it finds important for that layer. And basically that's what will set off a stronger signal. And you can see as we get deeper, we have these very complicated patterns going on here. And some of it's kind of, I don't know, it's almost like art in a lot of ways. So this right here, basically, it's just showing how you can visualize the convolutional layers to figure out like, well, what exactly are you doing within each part? Okay, so this actually came directly from the Keras blog, and you can see here, for example, those complicated patterns at the very end here. But I just wanted to share this and go through it, just to kind of look at it quickly. But this has a great example of like, you know, how basically we kind of like see the world. We'll talk about like, you know, a couple of applications that people have done to do this. But basically the idea here, and this is all done through Keras, so you can actually basically use this same model. In this case, we're actually using a model that was pre-trained. Basically, famous model called BGG16. Basically, it's a convolutional architecture, and it's already been pre-trained with all its weights, and does a pretty good job of basically classifying images. That's what it was built for. So I believe it was 2012 or 2013 when this specific architecture was released and shown. But anyway, basically, what they're doing here is they're essentially taking the model, and then what they're taking the certain specific layers and looking at the filters and actually applying those filters and not gradients, those filters on top with the weights already put in place, and see how it can change the image. So basically, you give it like sometimes a blank image and just say, all right, go ahead, go from this and just basically adjust until you have it maximized for that specific, you know, layer or filter. So you can see here they have this. So I would say this would be a good thing, seeing a Keras implementation of, you know, how to see these layers. And you can see here, this is the image originally. And so there's also an application of this. It was kind of going a little viral, more or less, called Deep Dream, which was made by Google. Basically, they took, I think, what is it, DeepMind? They took their network. I can't remember what network they did specifically. And basically, they passed in like images. So at first, you know, for example, static, and just see what comes out. So you can see here, these are the different patterns. For example, they found that maybe this pattern, for example, text looks like banana shape kind of stuff. But then what they started doing, more like an art project, they took pictures of actual like, what's it called? Actual pictures of the real world and said, okay, go ahead and take this picture and apply it to with one filter and say, go ahead and adjust this image until basically you have it high firing. So you can see for lower level filters, you can see it's finding these like kind of structural patterns and stuff. But what's really cool is that when you start actually using, I think you can't see this one too well, but if you start basically having more high level things, for example, it pointed at the clouds, kind of poetic, but you can see here is that, let's see if I can zoom in a little bit. Yeah, so you can see here, is it basically was saying, okay, like what do you see within this picture, and basically keep adjusting the picture until it maximizes what it feels is a good, you know, image. And you can see here, they actually point out specifically in the blog here that you can start seeing some interesting kind of like shapes, and it kind of fits well with the idea of it being called Deep Dream. Basically, it's like, what is the computer seeing within these parts? If we looked at just this, if we took part of the convolutional network and said, just focus on these parts of the filters and adjust the image to maximize what you quote unquote would like to see, right? So you can see here's some pretty kind of trippy stuff going on here. So you can see, take these original images and they took parts of the neural network that basically would say, okay, like things that detect birds and insects really well, things that detect buildings. One thing I find interesting about the building part and like these other ones is that you'll see, like, you know, for example, it's like, okay, a building, like it's learned how to detect buildings. You didn't tell it how to detect buildings. It learned like what defines a building. But what's interesting, I think, in this one in particular is that you'll notice that even though this network is optimized to detect buildings, you can kind of see that there's kind of like pictures of people kind of in here, like at least what, to me at least, look kind of like person-like things. And that kind of shows you a little bit of like the problem with, not the problem, but like one of the big areas of research right now is making sure when you train something that it actually is training on what you want it to. So for example, these buildings that were fed in for training might have also included pictures of buildings, but usually people were outside. So it actually used people probably to figure out if this is an actual building based on if there are people in front of it. And you can see here down at the lower end, which is closer to like what you'd expect in an actual building. So this can actually give a lot of insight on saying, you know, ways you can improve your convolutional network. What is your convolutional network actually looking for? And maybe figuring out, you know, ways you can maybe give it better training data. So for example, if you want to make sure it's just buildings and it's not looking for people down here, you might actually make sure that you have different images that are different what's it called, parts of the building. For example, you might cut it off so there's no people, it's only the higher level parts of the building. So like someone taking it from like the street going up. Those are kind of things that you would consider after kind of looking a little deeper into how your network's working. So you can go some pretty trippy stuff. It's also very artful. Like I think it's just a creative kind of thing. You can see here like different applications of people basically using this, or not people, but Google basically taking their network and reapplying it over and over and over again to basically create these very trippy kind of images and such. Okay. So this is one way you can, this is one way people have actually used to visualize their CNNs to actually, you know, one, do artful stuff, creative things, but also really just to understand what is your deep neural network doing, okay? So yeah, so this is a great blog post right here, and this follows up into DeepMind, which guaranteed if you talk about convolutional neural nets and basically trying to detect things, you'll probably come across DeepMind or Deep Dream. Okay, there is, let's see here, I want to say, okay, oh, this is the original for ImageNet classification. So just know that in here, ImageNet basically is a set of different pictures. There's a competition, and basically this particular structure, oh sorry, ImageNet is the actual structure. There was, oh shoot, there's a competition basically of different classification images for like lots of different images with many different classifications, and basically people would train across this. And you can see these very high level structures. I think this one, let's see, our net input is 150 by 208 dimensional. And you can see all the different layers, all the different structures here in this architecture can be quite complicated. And a lot of the times these very, very large architectures can take a long time going through. So this is why it's important to figure out how can we, you know, visualize each part, because all we would see as if we actually implemented this is your input, what you put in, and what it predicts to be out. But that's a lot of stuff going on here, and we would like to know how to structure this out and make this more usable. So anyway, you can see here, for example, looking at those specific filters here and seeing those different, I don't know if you can see that too well, but basically those different patterns and stuff within the, that the convolutional network is actually detecting. Okay, cool. So just know that the curriculum actually shows you how to do some of this stuff. There's also in that blog post, you can actually visualize all these layers. Any questions you have? So
far, so good.
Okay, cool. Yeah, it's a pretty cool thing. So, oh, I did want to show one part. There's this great experiment that you can actually build across. I actually wouldn't suggest going into this first, but it's kind of an interesting concept that you can kind of take in. It's on GitHub and everything. But this person here, what's his name again? Gene Kogan. I won't play this video, but I just want to show you. He basically built a way to visualize with a live webcam the different filters of a convolutional neural net. So you can see here on this right, on the left here is the convolutional neural network, and he's showing basically going through each filter. You can see, especially as he's moving around a little bit, you can see him the live filter of what different parts are, and you can see basically the dark areas are where things. Basically, this filter is saying, oh, that's not really important. And the lighter areas are basically, oh, that's a really important spot that I want to pay attention to. So for example, you can see here, this is convolutional network detecting more of his clothes structure versus his face, versus something over here might be detecting more like outlines and such. And if you look down here at this it's kind of blocking right here. On that left right here, down here, you can see mostly focused on his face. So you can see the convolutional network is basically finding different parts, high level features, and then also low level features. So kind of a cool thing to check out. Again, like this takes a little work to actually compile and everything like that, but you could do it. But I would suggest, you know, going into the Learn lab first before going into this part. But it's a really cool application just to kind of see what's happening. Okay. So this leads us to some applications you can do. So one application in particular, so I kind of showed a little bit, but one application in particular I wanted to talk about is adversarial networks, adversarial neural networks. And this is actually some research that was done relatively recently. And I say recently, like in the past, 2 years. I guess that's not recent anymore, but this was a big deal where basically one thing is that, for example, we can train convolutional networks and systems basically to detect images. For example, it can say, oh, this is a panda. But what they found in this research is that you can actually add in a specific amount of static and basically force it to be detect as a different image. So this is an important part, saying understanding how, because deep learning is a black box. If you just basically pass in just junk through it, it doesn't really know what it is. But what's interesting about this is that basically you can see this is a panda right here, but it only has about a 60% confidence. But by adding the static into here, basically you can convince the computer to say with a 99% accuracy that this is a gibbon, which is a type of a primate. And so what's interesting is that you can basically make it more confident that it's going to be a gibbon than it is a panda. And this is the stuff where it's like, okay, this is where we need to understand what's happening, because these two pictures look, to at least a person, pretty similar. But by having this extra static basically within the picture, the network is basically finding the wrong thing. So this is actually a big deal, for example, for self-driving cars. You want to make sure that if someone's doing, for example, image detection for a stop sign, make sure that it actually detects a stop sign, regardless of however it's graffitied or one adversarial attack is possibly. I think there is someone developed a sticker that you could put the sticker on the stop sign, and now networks wouldn't recognize it as a stop sign anymore, but yeah, this very small sticker on the stop sign. So you can see there's some interesting kind of applications and kind of not, I should say concerns, but also just ways you should be aware of to say, okay, making sure you have, how do you circumvent this kind of adversarial attack? An adversarial attack, is kind of, seems very scary, but it just means in general making sure your machine's robust and making sure that someone doesn't try to purposely, if you're trying to detect, let's say for example you are building something to detect pornography on a website, so you don't have images of pornography on that website. Well, if someone's familiar with basically adversarial attacks, it's possible they can basically if you're using a machine learning system to basically detect these images, whether they're pornographic or not, having extra, doing an adversarial attack, you could add in this extra static, which basically doesn't change the image to humans' eyes, but a computer basically will leave it unrecognizable. So kind of some interesting applications and some a lot of research right now going into saying, how do you prevent these kind of attacks? Okay, cool. So that kind of sums up for anything about visualizing neural network or CNN specifically. You have any questions, Assad, at all?
No. I'm gonna say no.
Okay. Yeah, it's pretty interesting stuff. But basically, I would suggest make sure you go through the Learn curriculum lab and stuff like that.
I think right now I'm trying to get an understanding of the use cases more so than the actual.
Yeah. Because it's kind of fun to do, but at the end of the day, it's like, well, why am I doing this? And the real reason is basically you're trying to figure out what is your convolutional network actually trying to detect. And that can be an important part of how you can improve it, because it is tough to understand what kind of structure do we give it for our CNN, which is really what it comes down to, is what kind of architecture do we have. All right, cool. So kind of speaking to that though, we have basically our different architectures, right, to help visualize. We can also do something, take that architecture and do something called transfer learning.